The National Electrical Code requires that the ampacity of conductors in a conduit be sufficient for the load they carry. In this situation, 2-inch conduits have 17 and 18 current-carrying conductors, respectively, with each conductor having an ampacity of 12.5 amps. Each circuit runs to 4 duplex receptacles, which have a load of 20 amps each. Therefore, the conductors violate the National Electrical Code requirement. Several options exist to rectify this problem. One option is to increase the wire size. Replace the existing 12-gauge wires with 10-gauge wires. This increases the ampacity to 30 amps, which is sufficient for the 20-amp load. Another option involves adding more conduits. Install an additional 2-inch conduit for each circuit. This will bring the total number of conduits to 3. This reduces the number of conductors in each conduit to comply with National Electrical Code requirements. A third option is to install a subpanel. Install a subpanel with 20-amp breakers in a nearby location. Relocate the circuits from the overloaded panel to the subpanel using 12-gauge wires for the runs. This will free up space in the original panel and comply with the National Electrical Code requirements. Several additional considerations should be kept in mind. The electrical contractor should also inspect the remaining circuits in the panel to ensure they comply with code requirements. The contractor should obtain a permit and have the work inspected by a qualified electrical inspector before closing the warranty period. The contractor should notify the dorm management or occupants that the electrical issue has been resolved and provide them with any necessary instructions or safety precautions. When dealing with multiple current-carrying conductors in a conduit, it's essential to understand the ampacity adjustment factors as outlined in the National Electrical Code. These factors reduce the allowable ampacity of the conductors based on the number of conductors in the raceway. These adjustment factors are found in NEC Table 310.15 Cone. For example, if there are 17 or 18 current-carrying conductors in a conduit, the ampacity of each conductor must be derated significantly. This derating is crucial for preventing overheating and potential fire hazards. When selecting a solution, carefully consider the existing infrastructure and the long-term needs of the electrical system. Increasing the wire size might be a straightforward solution for a small number of circuits, but adding conduits or installing a subpanel might be more appropriate for a larger number of circuits or if future expansion is anticipated. If choosing to add conduits, ensure that the conduit fill requirements outlined in the National Electrical Code are met. These requirements specify the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. Exceeding the conduit fill limits can make it difficult to pull wires, increase the risk of damage to the conductors, and reduce the conduit's ability to dissipate heat. Before installing a subpanel, determine the appropriate size and location. The subpanel should have sufficient capacity to accommodate the relocated circuits and any future expansion. It should also be located in an accessible location and comply with all applicable clearances and mounting requirements. When relocating circuits to a subpanel, use appropriately sized conductors and overcurrent protection devices. The conductor should be sized to carry the load and have an ampacity equal to or greater than the rating of the overcurrent protection device. The overcurrent protection devices should be sized to protect the conductors and equipment they supply. Remember that any electrical work must comply with all applicable codes and regulations. Obtain the necessary permits and have the work inspected by a qualified electrical inspector to ensure that it is performed safely and correctly. Neglecting to follow code requirements can result in safety hazards, property damage, and legal liabilities. Maintaining accurate documentation of all electrical work is also crucial. This documentation should include a record of the circuits relocated, the wire sizes used, the overcurrent protection devices installed, and any other relevant information. This documentation can be valuable for future maintenance, troubleshooting, and inspections. When working with electrical systems, always prioritize safety. To energize the circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not comfortable working with electrical systems, hire a qualified electrician to perform the work. Ensure that all electrical connections are tight and secure. Loose connections can cause arcing, overheating, and potential fire hazards. Use appropriate connectors and tools for the type and size of conductors being used. Avoid mixing different types of metals in electrical connections, as this can lead to corrosion and failure. Label all circuits and equipment clearly and accurately. This will help prevent confusion and errors during future maintenance and troubleshooting. Use durable labels that are resistant to fading and moisture. Regularly inspect electrical systems for signs of damage or wear. Look for cracked or damaged insulation, loose connections, and corroded components. Address any issues promptly to prevent them from escalating into more significant problems. When selecting electrical equipment, choose products that are listed or certified by a recognized testing laboratory. This ensures that the equipment has been tested and meets safety standards. Consider energy efficiency when selecting electrical equipment. Choose products that are energy efficient to reduce energy consumption and lower utility bills. When installing electrical equipment, follow the manufacturer's instructions carefully. Incorrect installation can void the warranty and create safety hazards. Ensure that all grounding and bonding connections are properly installed. Grounding and bonding are essential for protecting against electrical shock and preventing equipment damage. Periodically test ground fault circuit interrupters, or GFCIs, to ensure that they are functioning correctly. GFCIs are designed to protect against electrical shock by detecting ground faults and quickly interrupting the circuit. Replace any damaged or malfunctioning GFCIs immediately. Avoid overloading electrical circuits. Overloading circuits can cause overheating, tripping of breakers, and potential fire hazards. If you frequently experience overloaded circuits, consider adding more circuits or upgrading the electrical service. Use surge protectors to protect sensitive electronic equipment from voltage spikes. Voltage spikes can damage or destroy electronic equipment. Surge protectors can help absorb these spikes and prevent damage. Be aware of the potential hazards of working with electricity. Electricity can be dangerous if not handled properly. Always follow safe work practices and take precautions to prevent electrical shock. When in doubt, consult a qualified electrician. They can provide expert advice and perform electrical work safely and correctly. Regularly review and update electrical safety procedures. Ensure that all employees or occupants are aware of these procedures and follow them consistently. Promote a culture of electrical safety in the workplace or home. Encourage everyone to be vigilant about electrical hazards and to report any concerns promptly. Stay informed about changes to the National Electrical Code, or NEC, and other applicable codes and regulations. The electrical industry is constantly evolving, and it is essential to stay up to date on the latest requirements. Attend training courses and seminars to enhance your knowledge and skills in electrical safety. Continuing education is crucial for staying current on industry best practices. Share your knowledge of electrical safety with others. Help educate friends, family, and colleagues about the importance of electrical safety and how to prevent accidents. The National Electrical Code provides specific guidelines for the allowable number of conductors in a conduit based on the conduit size, wire size, and type of insulation. These guidelines are designed to ensure that the conductors can dissipate heat effectively and prevent overheating. NEC Chapter 9, Table 1, provides the maximum percentage of conduit fill allowed for different types of raceways. This table specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors based on the number of conductors in the raceway. The NEC also requires that conductors be derated when there are more than 3 current-carrying conductors in a raceway. This derating is necessary to account for the heat generated by the conductors. The derating factors are specified in NEC Table 310.15 current. In a specific scenario described, with 17 and 18 current-carrying conductors in a 2-inch conduit, the ampacity of the conductors must be derated significantly. This derating may reduce the allowable ampacity of the 12-gauge conductors to a value that is less than the 20 amp rating of the breakers. This is a code violation and must be corrected. The solutions described, such as increasing the wire size, adding conduits, or installing a subpanel are all valid options for correcting this code violation. The best solution will depend on the specific circumstances and the available resources. When increasing the wire size, it is important to select a wire size that is large enough to carry the load and has an ampacity that is equal to or greater than the rating of the breaker. It is also important to ensure that the wire is properly insulated and rated for the intended application. When adding conduits, it is important to ensure that the conduits are properly sized and installed. The conduits should be large enough to accommodate the conductors and should be installed in accordance with the NEC requirements. When installing a subpanel, it is important to select a subpanel that is large enough to accommodate the relocated circuits and any future expansion. The subpanel should also be installed in accordance with the NEC requirements. In addition to the solutions described, there are other options that may be considered. For example, it may be possible to reduce the load on the circuits by using more energy-efficient appliances or by reducing the number of receptacles on each circuit. It is also important to ensure that the electrical system is properly grounded and bonded. Grounding and bonding are essential for protecting against electrical shock and preventing equipment damage. A qualified electrician should be consulted to ensure that the electrical system is safe and compliant with all applicable codes and regulations.